what's up guys? So the next thing we're going to look at is lesson 4.9, which is dealing with similar triangles. So we're going to be learning ways that we can prove that triangles are similar, okay? Not congruent, but similar. Let's jump into it. All right guys, so the two postulates that we're going to look at today are angle-angle similarity and side-side-side similarity. So I want to make sure y'all understand, do not get this confused with congruent postulates. So we learned all these different postulates to use to find out if two triangles are congruent. We're using these two to figure out if they are similar, okay? Similar means not the same measurement, but they're the same shape, okay? So looking at the first postulate here is the angle-angle similarity. And what this states is, in two triangles, if two pairs of corresponding angles, this is so important that you guys understand this. Corresponding, I'm going to underline that. Corresponding angles, meaning the same angle have to be basically not like the same angle corresponding in the same spot of the triangle have to be congruent. Then the triangles are similar. And make sure y'all understand that if I just do a squiggly line, that means similar, okay? So with this being said, over here in my diagram, I have two triangles over here. And if you look, angle A here has one notch on it. Angle B here and over here has two notches. So that means those two are congruent. So that means since they're corresponding and congruent, that makes the two triangles similar. So then I could use their similarity to end up finding the measurement of a side that I need, okay? So we're just working on similarity, okay? So the same thing works with side-side-side similarity. So it says, if all three pairs, so it has to be all three pairs, it can't just be one and two, has to be all three pairs of corresponding sides of the two triangles are proportional, not congruent, proportional. That means if I write a proportion with the corresponding sides, and if all three of those match up, then that means it is proportional. Which means they're proportional, which means they're similar. So then I can use those proportions to find missing sides. The two triangles are similar, okay? So for instance, right now, if I took AB and YZ, those are corresponding, put those over each other, and BC corresponds with ZX, I put those over each other, and I put AC over XY and put those of each other. If each one of those are equal to each other, then that means the two triangles are similar. And I can, again, use that to basically find a missing side or help me to find a measurement that I'm missing here. Okay, so let's go and jump to the examples. All right, so on example number 1, it says determine whether the triangles are similar and then determine the postulate used to make this determination. Okay, so right now if we go ahead and look, I have two parallel lines right here. AB and CD are parallel to each other, okay? So automatically I know that these two angles right here are going to be congruent because they are vertical angles, okay? And so right now I have parallel line, and I have a transversal going through here, correct? You see that transversal? So right now, this angle right here and this angle right here are on opposite sides of the transversal, and they're inside. So we know alternate interior angles are congruent to each other. So that means those two congruent to each other. So right now we can go ahead and look. One angle, two corresponding angles. So these two triangles are going to be similar because of the angle-angle similarity postulate, okay? And so with this being said, now I could write a similarity statement. So I could say triangle ECD is going to be similar to triangle, and I have to write the same corresponding parts. So E is going to be congruent to E, B is going to be congruent to C, and D is going to be congruent to A. So that means these two triangles are going to be similar to each other because of the angle-angle postulate, okay? Now let's go look at example number 2. So on example number 2, it says, determine whether the triangles are similar and determine the postulate used to make this determination. So on the last one, we were given angle measurements. Now look here, we have sides. So the postulate tells me with the side postulate, it tells me that all the sides have to be proportional, okay? So what I'm gonna do is I'm gonna write a ratio from the smaller one to the bigger one, okay? So right now, if I look, Q and O is 13, And I'm going to say its corresponding side is going to be M and N, which is 26. Okay? So now right here, PQ is going to be 13. And then M and L is going to be 26. And then lastly, O and P is going to be 15. And then N and L is going to be 30. Well, right now, just by looking at this, two of these are going to be the same. But what we can do is we can simplify them to see if they're all going to match up. So 13 is half of 26, so that turns into 1/2. 13 is half of 26, so that turns into 1/2. And 15 is half of 30, so that turns into 1/2. So right now, ladies and gentlemen, all three of those are going to be the same, which means they are proportional. So what that tells me that these two triangles are going to be similar. So that means they are similar because of the side similarity postulate, okay? And so now I can write my congruent statement. So I can do triangle MNL, so MNL, okay? And I'm not putting equal, I'm putting similar, is similar to, and so right now, M is gonna be the same thing as Q, P is gonna be the same thing as N, and O is gonna be the same thing as L. So ladies and gentlemen, triangle MNL would be similar to triangle QPL because of the side similarity postulate, because they're all proportional, okay? All right, and lastly on example number 3, it says, determine whether the triangles are similar and determine the postulate used to make this determination, okay? So right now, if you look, it's showing me that all three of these are gonna be equal. So all three of these sides are equal and all three of these sides are equal, okay? So with that being said, I know both of these are gonna be equilateral triangles, okay? So equilateral triangles means all the sides are congruent and all of the angles are also congruent. So that means every single one of these angles is all going to be 60 degrees, okay? Same thing with this triangle. All the sides are going to be congruent, so that means all of these angles are going to end up being 60 degrees. So right now, if I look, corresponding angles are congruent, so all the angles are actually congruent. So I can prove that these two triangles are similar because of the angle-angle similarity postulate. So now when I write my similarity statement, I can do triangle EQU, I'll go ahead and do it that way, EQU is going to be similar to ISO, so triangle ISO. So with that being said, ladies and gentlemen, that proves that these two triangles are similar because of the angle-angle postulate, okay? So good luck proving the similarity.